Hello dear students, I hope you are doing good. I hope you'll have quarantined yourselves, and I hope you guys are taking all sorts of preventive measures as stated by the state and the central government. Since there's a lockdown, the colleges are closed, there are no classes going on. We are making a small attempt uh, to reach out to you guys in terms of academics by making such video lectures. Okay, to make this video, I have locked myself in my room. I've somehow managed to hang my phone up here and make this small setup, which you can see. And let me tell you, it was very, very difficult. I've kept the resolution of the video on the lower side, and you might hear some voices, some noises. The noise made by my fan right here, and my 6-year-old son is screaming and shouting and making all sorts of noises outside this room, in spite of many warnings. So in case you hear some noises, some disturbances, some background noises, I will request you to simply ignore it and focus on the topic. Alright, so the topic I am presenting you in this video lecture uh, is from the subject engineering graphics, of course, and the topic is orthographic projections from unit number 4, and it counts for 15 marks. Since we know uh, from the 6th unit we have in the syllabus, we just have the last 4 units for the end semester exam, and that is unit number 3, unit number 4, unit number 5, and unit number 6. Unit number 3 carries 8 marks, unit number 4 and 5 carries 15 marks each, and the remaining unit number 6, carries 12 marks. So the total of 50 marks, the subject carries 50 marks for end semester examination. The first 2 units are not included in the end semester examination. Since in the classroom we have completed unit number 1, unit number 3, engineering curves, unit number 6, development of lateral surfaces, and then we need to complete unit number 4 and unit number 5. Unit number 4 is orthographic projections, which will be seen, and unit number 5 is isometric projections. So in this video lecture, we'll be studying the basics of orthographic projections in 3 points. The first point will be about the introduction to orthographic projections, the classification of projections, types of projections, the difference between orthographic and isometric projections, etc., etc. The point number 2 will be about the first angle projection and third angle method of projection, and the difference between the two. We'll be studying that in detail. And the third point of this video lecture will be about we'll be taking a problem, a simple basic problem, just to get a clear understanding of how to draw an object, right? So we shall start with the video lecture. We'll start with the topic. The first point is about the introduction to orthographic projections. So what are orthographic projections and why are they important? Now suppose we have an object, let us say a rectangular prism or a duster. So a duster looks like this, alright, and let us say we have a source of light, like a torch. So we'll draw a torch, we'll try and draw a torch here. Okay, assume it is a torch, and then we put a screen behind this object. This is the object, this is the light source, and let us say we have a screen behind the object. So we have a screen. So when we switch on the light source, the torch, what happens is the light rays from this point source of light, they travel outwards they fall on this, and the same rays are then transferred on the screen, somewhat like this, creating a magnified image of this object, if you understand what I'm trying to say, right? There's a light source here, there's an object here in between, and then there's a screen behind this. So when we switch on the light source, what happens is the light rays, they come out, they diverge, right? They're diverging outwards through this contour, 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 the outline. They follow the outline of the object, and the rays of light, they fall on the screen behind this, and what we can see is the magnified image of this object. But what we are not getting is the true length of this side, we are not getting the true length of this side, we are not getting the true length of this side or of this side. What we are getting is a magnified image, an enlarged image. This image, this dimension and this dimension, they are not equal. Therefore, when we project an object on a plane or on a screen, if we need the true length of the dimensions of an object, what we need to do is we need to project these projection lines parallel. The projectors should be parallel to each other. Let me draw this on another page. Let me just keep it away. So if I take a similar object, a duster, it was like this. I'm so sorry. Okay, I'm doing this by one hand since my other hand is engaged holding a torch, a light source. All right. Okay. So we have another object, a similar object, right? A duster, and let us say we have a light source big enough in such a way that the rays of light coming out of the light source are parallel to each other. Therefore, the projections, all of the projections on the screen, this is the screen, let me tell you, and this is the object. So if the projectors, if they're drawn parallel to each other and perpendicular to the screen, so when they fall on the screen, if you join this, you join this, and you join this, you get a true length. Now in this case, this side is equal to this side and this side is equal to this side, and this side is equal to this side. The projectors are parallel to each other and the projectors are perpendicular to the screen. When I say perpendicular, I mean it makes 90 degree with the screen, like this. Let me draw it here also, somewhat like this. Yeah, so they're making 90 degree with the screen and they are parallel to each other. So the type of projections are orthogonal. Ortho, the name, as the name suggests, orthogonal projection means perpendicular projections. Ortho means perpendicular, 90 degree at right angles. So orthographic projections are, they play a vital role in cases where we do not want a scaled image, scaled up or scaled down image. Uh, it is required in case where we want the true length of the object. All right. So when we talk about orthographic projections, there are other type of projections as well. Let me give you a brief introduction about that. Uh, Type of projections. So we have parallel projections and we have perspective projections. Parallel projections are further classified into orthographic projections, oblique projections, and isometric projections. Perspective projection and oblique projections are not included in our syllabus, so we won't discuss that in much detail. If we get an opportunity to to be in a classroom where we get more time to discuss these topics, so we'll be discussing this in more details, perspective projections and oblique projections. So as for now, what is required is orthographic and isometric projections only. So this will be covered in unit number 4 and this is covered in unit number 5. So orthographic projections is mainly about um, converting a three-dimensional object into a two-dimensional planar figure. So as to simplify it, and isometric projections is about integrating all the two-dimensional images and combining it to form a three-dimensional object. So this is what the difference is. So I'll repeat: orthographic projections is about converting a difficult object, three-dimensional object into two-dimensional views, and the views include the front views of the object, the top view of the object, and the side views. The side views can be left-hand side view, the side view can be a right-hand side view. So orthographic projections, just hold on for a second. Yeah. So orthographic projections deals with the conversion of a three-dimensional object into two-dimensional views, whereas isometric projections deals with the integration of all the two-dimensional views, club them together to form a three-dimensional object. Orthographic projections are mainly used by the manufacturers. If a manufacturer has to manufacture a difficult component, let's say a difficult object, what he can do is he can put down the orthographic projections so as to convert the three-dimensional object into the two-dimensional views. So he can have a different perspectives, he can have different views, he can see the front view of the object, he can see the side view of the object, both side views, the right hand side views and the left hand side view. He can see the top view of the object. So basically what I'm trying to say is the manufacturer sees, he gets to see a lot more details. It also helps the engineers and the architects especially to view the structure, the design structure in different views. Okay, so there are two methods to draw the projections, the orthographic projections. They are first angle method of projection and third angle method of projection. So in order to draw the orthographic projection, we'll have to adopt either of the two. We'll either have to adopt the first angle projection method, or we'll have to adopt the third angle projection method. So we'll see in detail in the next point the introduction and the difference between first angle and third angle method of projections. So for that, I'll use this page over here. So I've drawn this before for making this video. So as for now, I will request you to ignore this and ignore this. Just focus on this part, this portion right here. Okay, so what we can see here is two planes, horizontal plane and a vertical plane, right? So vertical plane and horizontal plane, and they both are perpendicular to each other. This is what we can see. All right. Now what we can make out from this image is that there are four quadrants, right? This is the first quadrant, there's a second quadrant here behind this, the third quadrant behind this, and then there's a fourth quadrant over here, right? The first quadrant, let's say if I place an object, the object can be anything. It can be a pencil, it can be an eraser, right? It can be anything. So if I place this, let's say this sharpener, you can see this, a sharpener in the first quadrant, right? So we can say that the object is in front of the vertical plane, right? It is in front of the vertical plane and it is above the horizontal plane, right? So you'll have to try and imagine what I'm trying to say. If I keep the object in second quadrant, right here behind this, right? So we can say that the object is behind vertical plane and it is above the horizontal plane. Next up, if we try to try and keep this in the third quadrant, now we can say that the object is behind the vertical plane and it is below the horizontal plane. And what about the fourth quadrant? The object is in front of the vertical plane but it is below the horizontal plane, right? So first quadrant, second quadrant, third quadrant and fourth quadrant. Okay, so if we keep this object in the first quadrant, that is in front of VP and above HP, right? So let us say we hold this object like this, right? So it's a three-dimensional object, right? So what we are doing in orthographic projections, we are converting this into a two-dimensional view, right? Two-dimensional front view and top view. So if I am the observer observing this object from this direction, right? Look at the pencil, right? Follow the pencil. So if I am the observer, right, observing the object from this side, right, the front view will fall on the vertical plane, and the top view now I have to go above this, right? The top view will fall on the horizontal plane. Am I right? And for drawing this on the sheet of paper, what we'll have to do is we'll have to rotate the horizontal plane over here, right? The rule for rotating the plane is that the vertical planes will always be fixed, so it'll be locked like this and it'll be locked. Alright, the vertical plane will not move. The plane which will be moving is horizontal planes, right? Horizontal plane here and here. And the rule is that the horizontal plane will move in clockwise direction only. Alright, therefore when I say there are two methods, first angle and third angle of projections, and not second and fourth, the reason is that when we keep the object in second quadrant, let's say, right, and again we are observing this from here, right, the object is behind this plane, the object now is behind vertical plane and it is above the horizontal plane, right? The front view, the projections will fall on this plane, right, towards here. Let's say we have a light source behind this, right, that you have to imagine, and the top view is on the horizontal plane. Now the top view is on the horizontal plane and the front view is on the vertical plane, right? So when you have to rotate this horizontal plane, when we rotate this horizontal plane, the vertical plane and the horizontal plane, the image on vertical plane, that is the front view, and the image on the horizontal plane, the top view, they will coincide. Am I right? And similarly, in fourth quadrant, 1, 2, 3 and 4, this is quadrant number 4. If I keep this here, what happens? The front view and the top view. What about the front view? The front view will be on the VP. It will be right here, right? Since it is kept here, so the front view is here behind this, and the top view, the projections will project upwards on this plane. This is the horizontal plane, right? And once it is done, we have to rotate the plane so as to draw this on a sheet of paper, right? Since we have to draw this, we have to rotate this, right? We are not actually rotating it, we just, we have to imagine it. So when we rotate this horizontal plane clockwise, this vertical plane and this vertical plane will coincide, right? So the image of this object on the vertical plane, that is the front view, and the image of this object on the horizontal plane, that is top view, the front view and the top view, they will again overlap, right? Creating confusion. Therefore, we cannot use the second angle projection method and the fourth angle projection method. Therefore, there are only two types of projection methods. There is first angle and third angle, right? First angle projection method is when the object is kept in the first quadrant, and third angle projection method is when the object is kept in the third quadrant. So first angle projection method is quite simple, as we know. The object is kept in first quadrant. The front view of the object we get is on the VP, on the vertical plane, and the top view we get on the horizontal plane, right? And then we rotate this. So what we get is the vertical plane, the front view on the vertical plane and the top view on the horizontal plane. So if I have to draw this intersection line is right over here, right? This object, the front view is at the top on the VP, right? So this is the front view approximately like this, and the top view on the horizontal plane, and the horizontal plane has been rotated, so it will go down. It will look like, if I project this downwards, so it will look like this. So this is the front view and this is the top view. Alright, and what if I have to draw a side view? Let's say I have to draw a left hand side view, right? So we'll have to introduce a plane, right? One more plane. We'll need a plane. Okay, I'm drawing this freehand, and the pencil I'm using is Apsara extra dark pencil, which is strictly not recommended for drawing purposes. I'm using this since I want this to be very clear, this to be very dark, and therefore I'm using this. Otherwise this should not be used. Alright, we must use H grade or 2H grade of pencils. Okay, so in case we have to draw the side view of this, right, the left hand side view, so we have to look from the left hand side of this object, right? This is the front view, right? The top view over here, right? The left hand side view and the right hand side view will go from here, right? The left hand side view will fall on this side, right? The projections will fall behind this, right? The plane obtained is called as profile plane. We'll name this as PP, right? These are the principal planes, horizontal plane and vertical plane, and this is a profile plane. Alright, also called as the plane used for projecting side views. So this is the left hand side view, right? This is the object, and this is the left hand side of the object, and this is the right hand side of the object, right? So the left hand side view will be obtained over here, right? So the left hand side view will be on the right. Look here, the left hand side view will be on the right of the front view, and the left hand side view will fall over here. Sorry, the right hand side view, beg your pardon, the right hand side view of the object will come over here. This will be the left hand side view, and here we'll get the right hand side view. Okay, my 4 year old niece has joined the party and she's now making noises. I don't know whether you can hear it, but then I want you all to focus on this. All right. Okay. Now we'll study about the third angle projection. Now let us say we are keeping this object in the third quadrant, right? Over here, like this. Okay. All right, like this. Again, we are the observer, right? From here, right? We are the observer. Now the front view, the projections are falling over here, right? They're coming over here. Now this plane is in between the object and the observer, right? We are the observer. We observe it, since we are observing the object. We are the observer, right? And this is the principal plane. All right. So in this case, okay, the first angle projection method, the object was in between the observer and the plane, right? So this is the basic difference. In case of third angle projection method, the object is behind the plane. Okay, so what we are getting here is, if we are the observer, the plane lies between the object and the observer, right? The front view we get is on the VP, and the top view is projected on the horizontal plane. And once it is done, the plane is rotated, right? So the plane is rotated 90 degrees, so it will come here, right? So the top view which is on the horizontal plane will come above, right? And then the front view which is at the vertical plane will remain below, like this. So if I have to draw it over here just like this, all right, I'll try and draw this for third angle projection method. If it is kept here, right, the front view is on the vertical plane which is below this line, right, this intersection line. So this line I'm drawing here, all right, and then the front view. So the front view comes like this with whatever dimensions it has, right? So let us see. Yes, it is approximately same, all right. And the top view will fall on the horizontal plane, and then when rotated it comes above this line, right? So the top view, you have to project this, right? This is the top view and this is the front view, all right. So you can make out the difference. In first angle projection method, the front view is above the top view, right? It is above the reference line, and here the top view is above the reference line, right? The top view is above the reference line and the top view here is below the reference line. This is the basic difference we can make out, all right. Now the third angle projection method is taken out from the syllabus. So as far as unit number 4 is concerned, third angle projection method is not included, right? So we just have to deal with the problems involving first angle projection method only. That's it. Okay, now I want you to focus on this part, right, which I initially told you to ignore. This and this right here I've drawn is the symbol, the universal symbol for first angle projection method and third angle projection method. You have to see this and you have to remember this, right? This is for first angle projection, and this is for the second for the third angle projection. Okay, the first angle projection method is used worldwide. The Indian Standard Institution has recommended the use of first angle projection, whereas the countries like America and Australia, they use third angle projection method. Okay, so this was about the first angle and third angle projection method. In case you have any doubt, you can reach out to me. All right, now let us move on with the last point of the video lecture here is right here, this. All right. Okay, so I've drawn an object here. I'll read out the problem to you. The figure shows pictorial view of an object using first angle method of projection. I repeat. Draw number 1, front view in the direction of x. So I have shown the x direction, so you have to consider this as your front view, right? This as your front view. So this will be the top view obviously, and this will be the left hand side view, right? The left hand side view. And from here we'll have the right hand side view, left hand side view, right hand side view, top view right here, and front view. All right. So I repeat the problem. The figure shows pictorial view of an object using first angle method of projection. Draw number 1 front view in the direction of x, number 2 left hand side view, and number 3 the top view obviously. All right. So I'll try and draw this using I try and draw this freehand, not using scale or any other stuff. Okay, so you have to draw using first angle method, the front view first and then the top view, and then we'll try and draw the left hand side view. Okay, the first thing you have to do is draw a reference line, right? A horizontal line. So you have to draw this. Okay, I'll try and do it better. All right, use a scale. Okay, so this is a reference line. The first thing you have to do is draw the front view. All right, so to draw the front view you have to leave some space, right? You have to draw above this. So draw a vertical line, mark a point 10 mm or let's say 15 mm above this, and same 10 to 15 mm below. We'll take 15 mm above and 15 mm below. So from this point, this is a reference point, right? This point is actually this point. All right, so from this point, what is the distance here? The distance is 20. This is 20, 20 and 20. All right, so 20, 20, 20 is 60. So the total is 60. So we'll try and draw, let's say this makes 60. All right, okay, let me use another paper for this since we won't be able to draw the left hand side view. Okay, I'm using a different paper now. Okay, so this distance is 60. Okay, I'll mark here 60. It is this portion. All right, so I'm drawing it here, 60. Now I have to draw this, right? What we can see from the front view, we can see this portion, right? We can see this portion and we can see this portion in the front view. This is what we have to draw. That's it. All right, there are no hidden objects behind this, right? It is a quite a straightforward object, very simple object. So 60 by 40, so the height is 40, so I'll make this 40, right? I'll complete the block. What I can see is this line up to 20, so from this point 20 here, so 20 here, right? And then goes down to 20 again, it goes down to 20. Okay, so this distance is 20, the gap is of 20, so again 20 here, and then again it goes up, right? Again it goes here 20, so it goes 20 and goes down, so you have to complete this, so it'll complete, let's say, here. All right, try and okay, so this completes the front view. Now we have to draw the top view. All right, so for drawing the top view, what you have to do is you have to project these lines over here in the bottom. So we'll get the top view over here. Okay, so when we look at this object from above this, from top of this, what we can see is this face, right? So I'll mark it with different things. You can see this, right? And we can see this. All right, okay, this length, this distance is 30, is what we can see, right? 30, so this will be 30, so we'll start from here, this point, make 30, right? And then we have to complete it, right? What we can see is this edge and this edge, right? So from top, what we can see is a straight line from here to here. We can see a straight line, right? So straight line from here and straight line from here, so straight line from here, and then we have to close it. So what are the edges visible? The edges visible is this edge right here, this edge right here, and these two edges, one here and one here, right? So one edge, so you have to project this downwards, right? So this will be drawn using a thick line. So the edges which are visible has to be drawn using thick lines, and the edges which are hidden and which are not visible, we have to draw using dashed lines, right? And the projections using thin lines. So all the projections, these are the projections, they are drawn using thin lines, and the actual object is drawn using a thick line, right? So we'll see that in detail in the upcoming video lectures, where I'll try and use more colors so as to differentiate the different types of views. All right, okay, so we've completed the front view, we have completed the top view. Now we have to draw the left hand side view. So the left hand side view, right, the observer is observing the object from here, right, and we are assuming the profile plane behind this, right? So the left hand side view will project over here, right? So the left hand side view has to project when we observe this from the left hand side, right? We are observing the object from the left hand side, so we are observing from here, it has to come here, right? So draw a vertical line, again a reference line, extend this. Now the first thing we have to do is project these lines in this quadrant. So we have to draw the left hand side view. All right, okay, so what we can see from the left hand side is this face only, that's it. We cannot see anything else from this view, right, from this side. Anything hidden? Yes, there's a line which is hidden, this line, right, this line and this line, they're basically collinear from this end, right? So this line, so you have to extend that also. All right, and then we have to project these two lines. There is no other edge so as to stretch it out. Okay, now what we have to do is we have to project these projections in this quadrant, these two projections in these quadrants. So how to do it? There are two ways of doing it. The first way of doing it is use a compass, right? So you can use a compass, put it here, right, and draw an arc up to here, and then extend it. Again, put it here, draw an arc here, right, and then from this point extend it and join this. And this is the outline which is solid, right? From the side view, what we can't see is this line, right? So this line will be drawn using dashed lines, right? And another way of projecting these lines upwards is by drawing a 45, right? Instead of using your compass, if you don't want to use your compass, you can simply draw a 45 from here and 45 from here. One and the same thing, right? You can either adopt this method or this method, based on your convenience. Okay, now we'll do the dimensioning. So extend this, again dimensioning using thin lines, do not use thick lines. 20, 20 and 20. And we all know there are two types of dimensioning systems, unidirectional and aligned. So you can either adopt unidirectional, you can either adopt aligned. So this seems aligned. This is how much? This is the top view. The top view is 30, so this will be 30, right? And the side view, this is 30 and this is 40. So this part is 30